Hey folks, so for this screencast, I'm going to do a video on serial read and writing on an Arduino. It's kind of easy to use an Arduino to like send things to it and pull things from it. You can use pretty much any language to talk to it. I'm going to start off slow and just send like one character at a time and then move up from there. And then talk about some like higher order functionality that you can get to work if you want. I'm not going to do it in the video, but I'll just kind of talk about it. All of my Arduino Unos and Megas and Duos are all kind of being used in other projects. So I'm actually using a circuit playground here, and these are actually designed for CircuitPython, but you can actually use the Arduino IDE for it. And so I had to download the Adafruit Circuit Playground Express board. You have to go to the board manager to install that, and then I'm using Linux, so /dev /tty/mcm0. I have the Adafruit Circuit Playground, selected. Anyway, I have my void setup routine here where I just do serial.begin 9600. So this is the baud rate. There's a lot of different kinds of baud rates. 9600 is fine for me. If you want to do something quickly so that you don't like lose information, you might want to do like 115200. There's some standard baud rates that you can use, but for this purpose, I'm just going to use 9600. And then my loop, so this is the loop that runs all the time. I'm going to say, hey, if the serial port is available, if there's stuff in it, if it's greater than 0, that's basically what this line of code says. If there's serial available, I'm going to read that character and call it S, and maybe I should call it C for character, and then I'm just going to print it to the serial monitor. So if I think I pushed this, is it push, download? Here it is. Oh, you missed it. Okay, well it was downloading. Anyway, so I'm going to open up the serial monitor here and push this off. Oop, can I not? Okay, so I'm going to put it right here, and basically I'm going to just send it a 5 and hit send, and it's going to print out a 5. And then I guess I'm going to try and send it 10 and see, and look, it got 1 and 0. I'm going to send it 51023 and hit send, and it was able to read all of those characters and basically print it out. Now these aren't numbers, right? So if you send it a 5 or a 4, this is a character. You can't just multiply, right? So what you can do, which is kind of interesting, is you can actually say int. I'm going to call it invite, and the reason why I'm going to call it invite is because of all the examples that I read up on this. You use invite, but basically, when you're sending a character, you're sending a what's actually called an ASCII code equivalent. And so I'm gonna Google it and kind of show you what ASCII codes are. But you're not actually sending a string. You're sending because computers don't understand letters. Computers understand bits and bytes. And so really what you're doing when you're sending the number 5 is you're actually sending 531. Oh, okay. Yeah, so here's the other thing. 5310, you're like, whoa, I just sent it 5. If I send it 6, now it's 5410. Okay, that's really weird, right? So let's do a couple things here. First, let's do serial print a space. That way it puts a space in between. And I'm going to say if inbyte equals 10, and I'll tell you about 10 later. I'm going to serial print a /n, which is a new line. And I'm going to go ahead and push this code. Okay? And so now what's going to happen is I'm going to send it a 5, and now it's going to say 5310, and then you can't see the new line yet, but if I do 6, it's going to be 5410. Okay, so what's going on here? What happens if I send the capital letter A? 6510. Okay, how about AB? Now it's going to be 65, 66, 10. What about lowercase ab? It's going to be, oh, did I do something wrong? I must have accidentally sent an extra character. Yeah, maybe you guys will see it in the video because I missed it. So 97, 98, 10. Okay, so let's go to Google and let's type in ASCII codes here, and let's see what's going on here and see why I'm getting 65 and things like this. So if you look, here's the character in the red column, and then you've got HTML, oct, hex, and decimal. So if you look at the lowercase a, the decimal equivalent is 97. And if we go back to our serial monitor, that was exactly what I got for the lowercase a. So let's see what is 10 here. So if I go to the decimal equivalent for 10, I see that this is a new line feed. It's a new line. So when I am sending the serial monitor 5, I'm actually sending it 5/n. Okay? The /n is this what's called the non-printed character, so you don't actually see it. So how do I figure this out? Well, first let's figure out where 0 is. So 0 is a 48, right? So let's send. Oops, I don't want to show you processing yet. Let's send. I guess I killed the serial monitor. Let's send to 0, right? I'm gonna get 48 and 10. Okay. So let's say I just want to send the numbers 0 to 9. Okay, because all of those have single digits. If you notice, everything increments by 1. So if I just say, hey, if I want my number, I can just take my in byte and subtract 48 from it. And if my number is greater than or equal to 0, then it means it was a number, and I'm going to serial print number received equals, and I'm going to do serial print number. And then I don't have to worry about the /n, because when I get the 10, that's going to do a new line. And then when I do 10 minus 48, I'm going to get a negative number, and it's going to just switch to the second line. So it won't be a big deal. Okay, so here we go. So I'm going to open up, not available. Let's try again. Okay, so I'm going to send it the number 5. And there you go. It's going to say 53. That's the ASCII code equivalent. The number received was a 5. And then I guess I need to put a space after that. So let's do serial print space. Okay, and hit the push button here. All right, and then open it up again. I'm going to send it a 5, and it's going to say the ASCII code equivalent was 53. The number received was actually a 5 because I converted it from ASCII to decimal. And then I received a new line, and then I printed a new line. So let's try the number 9 now. The ASCII code is a 57. I received the number 9, and then I got a new line after it, and then I moved to the next line. If I send it 98, it's going to say 57, number received was a 9, and then I received a 56 after it, which is really an 8, and then a new line. Now the problem is I sent it 98, not 9 and then 8. So how do we get it to figure out that the two characters that I sent it are actually the number 98? Well, what you need to do is you need to tell the computer how many digits you're going to send it. So let's say we want to send a color, right? Well, a color is anything from 0 to 255, right? So we can just say like, hey, you know what? I'm going to send you 3 digits. So if I say int num digits is equal to 3, right? Anything from 0 to 255, then that means that anything that I send to it, the first number is going to be the 100th place. The second number is going to be the 10th place. And then the last number is going to be the 1's place. Like if you think about it, like the number 255 is really 200. It's really 2 times 100 plus 5 times 10 plus 5 times 1, or it's 2 times 10 to 10 squared plus 5 times 10 to the first plus 5 times 10 to the 0. Okay. So what I'm going to do is I'm going to make a place, or a like tenths place, hundredths place, and I'm going to make it equal to the power of 10 to the number of digits minus 1. Okay, and then what I'm going to do is I'm going to say, okay, int I'm going to call this in number, and I'm going to make the actual number a global and just call it 0. Okay, if the number that I received is greater than 0, I'm going to say let me think about this for a second. If I receive a number and it's valid and it's greater than, if it's greater than or equal to 0, if it's a valid number, I'm going to take, not number, but in number. Okay. I'm going to take number, and I'm going to just use this formula here, which is sort of like a recursive formula. I'm going to say plus equals the in number times the place. And then I'm going to take the place and I'm going to slash equals 10. Okay? And the reason why I'm going to slash equals 10 is because originally it's 100, and then you divide by 10, you get 10. And then 10 divided by 10 is 1. Eventually, and then the way the serial monitor works, though, is eventually I'm going to send it a new line, at which point what I need to do here is I need to say number equals 0 and place equals, and basically reset the place back to this up here. Okay. Let's see how this works here. I'm just curious what happens. Oh, I haven't printed the number. Ooh, I want in number, so I don't want to push that yet. I think here I want to say serial print final number. I'm going to say, instead of number received, I'm going to say digit received is in number. And I'm going to say final number received equals serial print. Right before I reset it, I'm going to call this number. And then I'm going to do a serial print. Actually, I don't need to do a space, because if I receive a 10, I want to print a new line. And so I'm going to put this here and this here. Okay, and then now it should expect 3 numbers, and I should be able to send it 255. So let's see what happens. Whoa, that's a lot of stuff. Okay, so it first received 50, which is actually a 2, and then it received a 53, which is actually a 5, and then it received a 53 again, which is a 5, and then new line, and then the final number is 255. Let's try 102. Okay, so it received a 49, it received a digit of 1, then a 48, a digit of 0, and then a 50, a digit of 2, and then when it put it all together, it got 102. Now, just to prove to you that this is actually doing what it is, I'm going to do int computation is number times 4, okay? And then I'm going to serial print a space, and then serial print computation. And then so if I flash this code here, I should be able to send it, 156, and you'll see I received 156, and if I multiply it by, what did I multiply by? 4. 156 times 4 is 624. There you go. So I have essentially successfully created a way to send a 3-digit number. And you can send as many digit numbers as you want. Now, the reason why I did this is because, first of all, I want to get rid of this computation. The reason why I did this is because what I want to do is I want to turn the LEDs on this thing. So the nice thing is you can pound include Adafruit circuit playground.h. I think that's what it is. Let's try that. Okay, and then I think you need to do circuit playground.begin. Okay, looks like we're still in business. I'm doing this all from memory. And then here I want to do circuit. I want to just turn all of them on. For int I equals 0, I less than equal to 9. I think there are 9 pixels or 10 pixels. Oh, I forgot it does autocomplete of the curly braces. And then I want to do circuit playground dot set pixel color, and then the pixel, and then the color. So I'm gonna do the number. So it's gonna be all whites, and I'm basically just gonna change the brightness. All right, let's see if that compiled. IDX, oops, I. Okay, so now I'm going to hold up my circuit playground here, and I'm going to turn on the serial monitor, and I'm going to send it 100. Or I think the lowest that you can do, I forgot to show you something. I'll show you in a second. I'm going to send 070, and the leading 0 is really important because remember, the computer is expecting 3 digits. So if I send it that, I get a 70, and none of the lights came on. Great. Okay, let's try 100. None of the lights came on. Of course. For int I equals 0, I less than equals to I plus plus, set pixel color, number. Let's try 255. Wait a second. It's still printing. I must not have flashed the code. I thought I did. Because it's still printing the times 4. And could have sworn I deleted that. Okay, 255. Aha, okay, so they're all on. Let's send it 100. See, not as bright. Let's 070, even less bright. 060, less bright. 050, 010. When do they turn off? There you go. There, it turns off right there. So I can basically control the brightness of this by sending this number. Now, why am I sending it 070 instead of 70? The reason why is because if I send it 70, it's going to think it's 700. You see that? Because it was expecting 3 digits. And it's just going to assume that that first digit is the hundredths place. And so unfortunately, this is just the way I set this up, and this is how you have to communicate with my board. You know, there are tons of different serial communication protocols. Okay, at this point, let me send it 000 so I can, because it's kind of bright over here. Okay. At this point, I have code on the Arduino that can read numbers coming in. What I want to do now is I want to comment out all of these serial prints. Everywhere that there is a serial print, I want to get rid of it. Because what I want to do now is I want to control the circuit playground from a program called processing. Okay, so I'm flashing the code, and then I'm going to send it 255, and hopefully I'll send it and nothing will pop out. Good, so all the lights came on but nothing popped out. If I send it 000, I'll turn off, nothing popped out. Okay, cool. So now what I want to do is I want to use this program called processing. So processing is a really neat code because what you can do is you can, it's very, very similar to Arduino. You have a setup function and a draw function. It opens up a window and you can kind of do things with it. So this code right here is very similar. It's basically saying, like, you know, if the Arduino sends something to processing, you can read it. But I actually want to send stuff to the circuit playground. So I don't want to do anything here. I just want in the draw loop. I just don't want to do anything. I actually I want to make a function called mouse. I think it's called clicked. I want to send it the number of my mouse. Okay. So what I need to do is I need to come up with a int color is the current Y position of my mouse times divided by the height of my mouse of the entire window times 255, and then I'm just going to print the color, and then I'm going to print a new line. And the way processing works, all the prints will pop up down here. And so here I'm importing the processing serial library. I'm creating an object for that, and then I'm using the /dev ttym-acm0, and then I'm going to make this a 500 by, well, actually, I don't really care about the width, but I want a long window. And then it says unexpected token. Maybe color is a built-in function, so let's call it CPX color, and that will hopefully get rid of my syntax here and syntax error. Okay, sweet. So I have this really long window here, and if I click anywhere, oh, it's because it's an integer. You have to do mouse Y times 2. It's mouse Y is an integer and height is an integer, and so if you do mouse Y divided by height, you're going to get a number less than 1, and then you convert it to an integer, and then it just truncates it to 0. So let's try this again. So now if I click here, I get 127. Up here, I get 17. Down here, I get 237. Sweet. Okay, so now what I want to do, though, is I have this integer, and I need to convert it to a string of characters. And so hopefully, I think what I can do is I can say string equals string of CPX color. Variable, S. The value of local variable is not used. Duh. Okay. Print space and then print the letter S. Okay. And then boom. Okay, so if I click, I basically get the same number back to back, except the second one is a string. Okay, so now I think in order to send it to the circuit playground, I need to do for int I equals 0, I less than s dot length. I think that's a built-in function. I plus plus. See, this one doesn't have auto-completed curly braces. Man, my typing is subpar here. So what I want to do is I want to print, just to make sure this is working right, I want to do print s at car at I, and then I want to print a space, and let's see what happens. Okay, let's do this. Let's print a space up here, and then let's print periods between the letters, or the digits. And there we go. So, okay, so the number, the integer is 123, the string is 123, and then I'm printing a space, a 1, a period, a space, a 2, a period, a space, a 3, a period. Okay, so now what I want to do is I want to do myPort.write, and I want to send it s.car at I. And then, remember, I need to send it a new line because the Arduino, remember, is expecting a new line. And so I'm going to hold up my circuit playground here. Hopefully, I should be able to click down here and the lights light up, 243. And if I do here, 97, ooh. So here's the issue, right? I need to make sure that I'm speaking the same language. So when I sent it 97, the Arduino, the circuit playground thought that I was sending it 970. So I need to say if s dot length is less than 3, I need to do a for int I equals 0, I less than s dot length, oh gosh, minus, no, 3 minus s dot length I plus plus. And then let's do serial, just to make sure this is working right, I'm going to do print space, print a 0, and then print a period. And let's see if I send it a 97, 034, and what about like really small numbers? Yeah, 006. Okay, cool. So then all I need to do is do a myPort.write and just send it a 0. Okay, so now I should be able to, I sent it 14. There we go. Now the lights are off. 003, 185, 240, 010. Do you guys remember how when the lights turn off, that's like 18, 27. When did the lights go off? Like under 10? Okay, let's test that. Let's just run the serial monitor and let's send it 010. Okay, what about 011? 020? Is it? Oh, I wasn't paying attention. 010? 011? Yeah, they light up at 020. Okay, so let's run processing again. If I send it 032, 025, 016. Yeah, that is curious that they turn on 017. Huh. Okay, well, I mean, I think I sort of exhausted this video. How long is this video now? It's a 25-minute video. So hopefully this helps with like sending ASCII code variables and reading them. I mean, I could do the same thing on the Arduino side. Like here where I do myport.write, I could easily on the Arduino do serial.write and just send it a byte to processing. And then in processing, I could do myport.read and read. And I could have the Arduino and the computer talking to each other back and forth and do like, hardware in the loop simulations and things like that. Sending single digits like this is terrible, because if you send the number 1000, you have to send it 4 digits. But if you converted it, and binary would be even worse, because the number 1000 in binary is like, I don't know, 101 to 1111 or something like that. So you have to send a ton of digits. But if you do like something like hexadecimal, the number 1000 here, 1000 in hex, it's 3E8. So you have 4 digits, suddenly you only need 3 digits. And so you want to compress it to as few digits as possible that you send to the other computer. So typically what people do is they'll take a decimal number and they'll convert it to hex and then send it over. And then the person or the computer who gets it will grab that hex data and convert it back into decimal. I didn't want to do that in this video just because you can probably Google one of these and figure out how to convert it, but it's basically the same thing. Instead of having like a tens place or a hundreds place, you have a 16th place and a 16th squared place, whatever that is. Anyway, I hope you enjoyed this video for Arduino and processing. All of my code is on GitHub. I have a processing.git GitHub. I'll post in the link in the comments, and then I have a microcontroller.git as well, and I'll post that in the comments. Anyway, I hope you enjoyed this video, and I guess I'll see you in the next one.